guys, it's Mrs. Glenn. This section is 1.1 polynomials, and in this section you'll be able to identify, justify, and create polynomials. So let's get started. First question is, you and your friends are going to Busch Gardens and you're going to buy the refillable souvenir cup for fountain drinks or icy refills. On the day you purchase the cup for $14.97 after tax, your refills are free for the rest of the day. On future days, it costs $1.06 for fountain drinks refills and $2.13 for icy refills. A. Use an algebraic expression to describe how much you spend after tax based on purchasing the cup and the number of refills after the first day. So the first thing you need to look at is that $14.97. That is the charge for the cup. So you're automatically going to be charged that. Doesn't matter how many actual drinks you drink. Next, you're going to be charged $1.06 per fountain drink. So we're going to use F to represent the number of fountain drinks you drink, and for each one of those they're going to cost $1.06, so that's multiplying with the F. And then the last kind of drink you can get is the icy, and that's $2.13, and we're going to use I to represent that, so that's every icy would be $2.13. So that is the expression that we're going to use to answer A, B, C, and D. For B, if you purchase and use the cup the first visit, then come back again and get 4 fountain drink refills, how much will you have spent on the drinks after the tax? So again, the $14.97 and the $1.06 for the fountain drink and the $2.13 for ices. But you'll notice in B, they never mention that you're going to get an icy. So instead of writing any number in the I, we're going to write 0. So we're going to replace the F with a 4 because you're drinking 4 of them, and you're going to replace the I with a 0. And then you just calculate everything and add them together. So $4.24 is $1.06 times 4, and 0 is what 2.13 times 0 equals. Then you add everything together, and it's $19.21. Make sure you include your dollar sign in front because this is a real world problem and we're talking about money. C says a friend meets you at Busch Gardens and he already has the cup from his last visit. This time he gets 2 icy refills and 3 fountain drinks. How much has he spent in total on the drinks at Busch Gardens? So remember that $14.97 that he has to pay for the cup? He already paid that, but he still had to pay that in order to get his drinks. So you need to make sure you include that. And then you have the $1.06 for fountain drinks, and he gets 3 of those. So we're going to change the F to a 3. And $2.13 for the icy, and he got 2 ices, so we changed the I to a 2. And then we're going to multiply everything together, and we get $1.06 times 3 is $3.18. 2.13 times 2 is 4.26. And then the last step is to add everything together, and you'll get $22.41. And don't forget to make sure you have your dollar sign in front. For D, it asks you to write an expression combining your friends and your amount that you spend on the drinks that you spent on your second visit to Busch Gardens. So this way you can actually go back and add everything together and make it a little bit more complicated, or you can create a new expression and solve it from there. So the first thing you're going to want to do is come up with some new variables. The first variable is C for the total cost of cups. So you have your friend's cup and your cup, so that's 2 cups, so 2C. Then if you look back, you'll notice that your friend had 3 fountain drinks and you had 4. Let me just double check that. Yes. So that's 7 fountain drinks, so that's where the 7F comes from. And then you did not have any ices, but your friend had 2, so then you have 2I for your last term. So now all you have to do is substitute in what each thing costs. So for the cups, that was $14.97. Each fountain drink was $1.06, and each icy was $2.13. So you substitute that into where the letters are, the variables, and then we're going to multiply each of the terms together and add them up for the final answer to see how much in total your friend and you spent on the second day. So you have 2 times 14.97, which equals 29.94. 7 times 1.06, which equals 7.42, and 2 times 2.13, which equals 4.26. And after you add everything together, you get $41.62. Again, don't forget your dollar sign. All right, next section, we're going to be completing this table with a mathematical expression. This is called translations. This is taking words and translating them into mathematical expressions. So the first one is the product of a number and 8. Product means multiply. So we're going to take any number, and we don't know what that number is. So in algebra, we use letters or variables. So we're going to use n for this one. And then we're multiplying it with 8. So anytime you multiply a number and a variable together, you smush it together and put the number first. So we're going to put 8 in front and n at the end. So 8n would represent that expression, or that translation. Then the next one says 7 less than. Well, less than means subtraction. 4 times a number. Times means times. So we have two operations going on in this one. So 7 less than 4 times a number. So let's start with the 4 times a number, which is 4n, and then subtract 7 from that. So 4n minus 7. 7 less than 4 times a number. So that tells you need to write the 4n first because 7 is being subtracted from it. It's not going to have negative 7 first and then plus the 4n at the end. You're subtracting the 7 from the 4n. Then the third one, 11 divided twice a number. So you have 11 in front or on top of your fraction. Either way you can write it. Divided by twice the number, we're going to use n again. So 2 times n or 2n. Then the next one says 16 decreased by a number. Decreased means subtraction. So we have 16 and we're decreasing it by a number. We'll use n again. So we have 16 minus n. And the next one is sum. You've learned that word back in elementary school. Sum means adding everything together. So you have the sum of 4 and a number. So again, we'll use n, and the number is 4. So we have n plus 4. We always list the variable first if we can. You'll see some of the problems we don't because of the way that their wording is. But we try to list the numbers or the letters first, the variables. Then the next one is actually a scenario. So we have depositing $20 a week into a bank account with a current balance of $300. So if you're trying to figure out how much money is in the bank account, you have to always include that $300 that you had in the very beginning that you deposited, but then include all of every week that you're depositing $20. So $20 a week would be 20W or 20N, and then 300 would be the original amount that you deposited. So you have to add that in at the end. And the last one is you save $30 a week. How many weeks will it take to save $1,200? So that is actually an equation because you have it equaling a total of $1,200. So you have 30n equaling 1,200 or 1,200. Then you would just divide by 30 on each side to figure out how many weeks it would take you to save 1,200. Then the next one is creating a storyline or a word problem when you're given a certain algebraic expression. So this is working backwards. You're given an expression, you have to create the problem. So A is 35 minus 5B. So I just created one that says you have $35 to ride the fair rides. If each ride costs $5, write an expression to show how much money you would have after riding B rides. Then for B, 750W. And you send 750 texts in a week. Write an expression to show how many texts you send in W weeks. So you just take the expression and work your way backwards to create the problem. And now we're going to fill in the table. So you have types of polynomials, number of terms, an example for each one. And remember, standard form is where the variables need to be in order from alphabetical first, and then the highest degree to lowest degree. So starting out with monomial, M-O-N-O is mono, which is 1. That's the prefix for 1. So that would be number of terms is 1. And you can create anything you want. My example, it would be 2n, just because we've been using n all along. And then for binomial, bi, like bicycle, has 2 wheels. Bi means 2. And then for example would be 2n plus 3. And terms are separated by plus and minus signs. So you'll notice that the second one has a plus sign, and that means there's two terms because they're separated by plus signs. It's kind of like a divider. This one does not have any plus or minus signs, so that's just one term. And then trinomial has three terms. Tri, tri like a tricycle, has three wheels. And then I'm just adding on to that, so I have n squared in the front, then our 2n plus 3 at the end. So there's two plus signs here, which means there's three total terms because they have dividing by the dividers in the middle, which is your plus signs. And then the last one is 4 or more. So we don't continue to name all of the polynomials. After we get to 4, we just say anything 4 or more is called a polynomial. And an example would be n to the third power plus n squared plus 2n plus 3. And that would be a 4-term polynomial. And that's how you do this table. And then we have our last page, I think. Yes, going on to the last page. We are going to finish up by talking about the degrees of each one and if it creates a polynomial or not. So for this one, just to check, make sure that you're understanding expressions so far with polynomials. If not, make sure you go back and watch the video again. Any parts that you need to rewatch, this is the great thing about videos, is that you can go back and rewatch them. If you're understanding so far, then keep going. The first one is for the directions, make sure that you name the type of polynomial and then state the type of polynomial. That's the same thing, Mrs. Glenn. So that's actually supposed to be state the degree of the polynomial. So for this one, you have, yes, it's a monomial. And remember, the degree is based on how many, when you add up the exponents. So we have 2 plus 4, so this should be a 6-degree polynomial. And this is not in the video, so I'm checking to see if you actually listen to what I'm saying. So in this problem, I want you to make sure you have in your table that you have 6 degree under here. Then for part B, you cannot have a variable in the denominator. That does not make a polynomial. So if there is a variable in the denominator, you immediately say, nope, not a polynomial. Part C, that is a polynomial, and it's called a trinomial because there's 3 terms that are separated by a plus sign and a minus sign. And then for this degree, again, like part A, you're going to write the degree underneath if you're paying attention. And you've got, you have to add up each exponent and each term and see which one is the highest. So for this one, 2 plus 3 is 5. There is an exponent here of 1. So 1 plus 4 plus the other one that's on the C. So 1 plus 4 is 5, plus 1 more is 6. And then this last one is just a 2. So this is actually a 6-degree polynomial because this middle term has 6 degrees in it. So underneath your answer for this one, you would write 6-degree polynomial. And then part D, no, it is not a polynomial because of this negative exponent right here. You immediately stop and say this is not a polynomial because it has a negative exponent. And now we're going to move on to the last section. So you're going to answer the following for the given polynomials. So when you're given 5x squared plus 4x to the third minus 2x to the fifth plus 3, the first thing you want to do is put it into standard form. So we need to first find the highest exponent. And the highest exponent is that fifth x to the 5th degree. So that goes in front. And you'll notice that I also included that negative that's in front, that minus sign. It always includes the front sign. So whatever you rearrange them, pull that front sign in the front. So you have negative 2x to the 5th. Then the next highest, there's no 4, so we go to the 3. So that's plus 4x to the 3rd. Then the next highest would be that 5x squared because 3 doesn't have an exponent. And that 5x squared, there is no sign in front, so that's automatically a positive 5x squared. So we put plus 5x squared. And then the last is plus 3. So then you're going to look to see what degree it is. Again, we're just adding the exponents, but there's no multiple variables in each term. It's just one variable, so you can just look at the highest one, which is a 5. So this would be a 5th degree polynomial. Then you're going to add how many terms for part C, and they're separated again by plus and minus signs. So you have 1, 2, 3, 4. And then the leading term is the entire thing, not just the 5 or the x squared, but the entire thing together. So that's, I'm sorry, not the negative 2 or the x to the fifth power, but it's the entire thing, because remember, they're asking us the leading term after we put it into standard form. So negative 2x to the fifth power would be the answer for D. And then the leading coefficient, the coefficient is just the number that's in front. So that's the negative 2. The coefficient of this one would be 5, this is 4, and this is negative 2. So the coefficient, leading coefficient would be negative 2 for this answer. And then the last question we have is this big long one, 3a squared b plus 4a squared plus 2b minus 5ab squared plus b squared. So first thing we're going to do is put it into standard form. So the highest a value, remember going alphabetical first, the highest a is this 3a squared. No, it's not. It's the 4a squared, because this 4 means there's 4a squareds. This is only 3a squared. So we put the 4a squared first, then the 3a squared b. Then you have minus 5a. We go to this one because this is the next highest a value. These two terms do not have an a. So this is the next one. And then we're going to go to our b values. B to the first power is smaller than b squared, so we're going to list b squared first. Then our last would be 2b. So that's in standard form. And if you're wondering what are these little caret signs that are in between the a and the 2, that's denoting that that is an exponent. So it's actually above your 6 on your keyboard. And so when you're trying to type an exponent, you can just hit Shift 6 and it'll give you that little caret sign, and that's how you show that it's an exponent. So you show that it's being raised up to that number. And then part B, what degree is that? So we're going to go in and we're going to add everything together. This is a second degree. This is a to the second, that's 2, plus the 1, that's 3. So this term would be a third degree. Then this is a 1, this is a 2, so 1 plus 2 is 3 there. This is just a 2, and this is just a 1. So these two have both third degree, and that's the highest degree out of the entire polynomial. So this is a third degree polynomial. Then how many terms are there? Just separated in between plus and minus signs, so you count them. 1, 2, 3, 4, 5. So 5 terms. The leading term is 4a squared. You just copy down after you write it in standard form. And then the leading coefficient is just the number in the front, which is that 4. So it's just the number.